Hello, precious one. I welcome you once again into Kenya Akon Mathematics Classroom. In this particular episode, we are going to look at polynomial functions. We are going to look at polynomial functions. Polynomial functions. Now, we will look at the general idea of a polynomial function. Now, when we talk about a polynomial function in X is any function that can be expressed in the form f of x equals a naught, you have x exponent n plus a1 x exponent n minus 1 plus a2 x exponent n minus 2 plus up to a n. And so any function that can be expressed in the form f of x equals a naught x exponent n plus a1 x exponent n minus 1 plus a2 x exponent n minus 2 plus up to plus an is what we call the polynomial function. Now, our x is a variable. X is a variable. Then our n is a definite. It's a definite positive integer. Then a naught, a1, a2, and an are constant coefficients. We call this constant coefficients. Okay, so any function that can be expressed in the form f of x equals a naught x exponent n plus a1 x exponent n minus 1 plus a2 x exponent n minus 2 up to an is what we know as the polynomial function. Now, x is a variable and n is a definite positive integer. N is a definite positive integer. And a naught, that's a naught, a1, a2 up to an are constant coefficients. And these constant coefficients, some of them can be 0, but the a naught must not be equal to 0. The a naught must not be equal to 0. And there is a reason why we are saying that the a naught must not be equal to 0. Take note that when you are given a function, or let's say a polynomial function, it is the highest exponent of the x that determines the degree of that function. Very soon I will explain what I mean by that. Let's assume that we have this polynomial function f of x equals, we have 2x cubed minus 5x squared plus 6x. Let's say you have minus 12. This is a polynomial function. Let's assume that we have f of x equals, we have x squared minus 5x plus 6. Then let's say we have f of x equals 7x plus 11. All these are polynomial functions. But when we look at the first function, f of x equals 2x cubed minus 5x squared plus 6x minus 12. This is a cubic polynomial because the highest exponent is 3. Now, because the highest exponent is 3, this is a cubic polynomial. The coefficient of the x cubed term is 2. We are saying that now, because the highest exponent of the variable determines the degree of that function, if the constant coefficient is equal to 0, then it used to be a cubic function. And that is why for every function, the coefficient of the highest exponent that determines the degree of that particular function must not be equal to 0. And that is why we said that the constant coefficient a naught, a1, a2, and an, some of them can be equal to 0, but the a naught, the coefficient of the variable that carries the highest exponent, must not be equal to 0, so that the function can be defined. So this is a cubic function because the highest exponent is 3. This is a quadratic function. The highest exponent is 2, and this is a linear function. The highest exponent is 1 because 7x exponent 1 is the same as 7x plus 11. So we can see that some of the constant coefficients can be 0. So any polynomial that can be expressed in the form f of x equals a naught x exponent n plus a1 x exponent n minus 1 plus a2 x exponent n minus 2 up to an is what we know as the polynomial function. Is what we know as the polynomial function. Now let's look at. Now we are going to consider algebra in polynomials. Now with the algebra in polynomials, what we are talking about is addition of polynomials, we have subtraction of polynomials, we have multiplication of polynomials, then we also have division of polynomials. So we are going to look at what we term algebra in polynomials. So we have what we call the algebra in polynomials. And with the algebra in polynomials, as I said earlier, we are going to look at addition of polynomials, subtraction of polynomials, multiplication of polynomials, and division of polynomials. So first, let's look at addition and subtraction. Addition and subtraction of polynomials. So we are going to explain the addition and subtraction of polynomials by looking at some examples and how best we can solve the problem. Now let's assume that we have these two polynomial functions, f of x equals, we have x cubed minus 2x squared, then we have 3x, then our g of x is also equal to, let's say we have x cubed plus 4x squared, then we have minus 7. Let's assume that these are the two polynomials that we have. Now let's add another polynomial. Let's say we have h of x to be equal to, then we have x cubed, then we have plus 2x squared, then we have plus 6. Let's assume that these are the three polynomial functions that we have. We can see that the first one is a cubic function because the highest exponent is 3. The second one is also a cubic function. The third one is also a cubic function. Now let's assume that we are asked to find I, f of x plus g of x. We are asked to find f of x plus h of x. F of x plus, let's say we have 2 times g of x, and IV, let's say we have 2 times f of x plus 3 times g of x. Okay, so let's assume that this is what we are given. Now we are looking at algebra and polynomials. And first of all, we are looking at addition and subtraction of polynomials. So these are the three functions we are given: f of x, g of x, and h of x. And all these are cubic functions. You can see that the highest exponent is 3. And it's the highest exponent of the variable that determines the degree of that particular polynomial. So this is a cubic polynomial, a cubic function, a cubic function. Okay, so we have to find f of x plus g of x, f of x plus h of x. Then we have f of x plus 2g of x. Okay, because we are looking at addition and subtraction, then let this one be minus 2 times g of x. Okay, so now let's look at how best we can solve the problem. The first, we have to find f of x plus g of x. So when we ask to find f of x plus g of x, don't forget that we know the polynomials f of x and g of x. So f of x is x cubed minus 2x squared plus 3x. So we are adding, we have x cubed minus 2x squared plus 3x. We are adding this to, okay, let me bring it down here so that we can simplify it easily. So f of x from the question is x cubed minus 2x squared plus 3x, then plus g of x, and g of x is x cubed plus 4x squared minus 7. So now with, you can put your f of x in brackets, then the g of x also in brackets. Now with addition of polynomial functions, we only add the like terms together. That is all. So we can see that we have an x cubed term here. We also have an s cubed term here. So s cubed plus s cubed. Remember that the coefficients are all 1. And so we have s cubed plus s cubed, and this will give us 2x cubed. Then you also have minus 2x squared. There's another s squared term here. That is plus 4s squared. So minus 2x squared plus 4s squared will give us plus 2x squared. Then plus 3x. There is no x term here, so we have plus 3x. Then there is no constant here, but another constant here. There is no constant here, but there's a constant here. The constant here is minus 7. That means that if we add f of x to g of x, we are getting 2x cubed plus 2x squared plus 3x minus 7. So with addition of polynomials, we add the like terms together. That is all. Now let's look at the second part of the question. We have to find f of x plus h of x. Okay, so f of x plus h of x. This would be equal to f of x is still x cubed minus 2x squared plus 3x plus h of x. H of x from the question, h of x is x cubed plus 2x squared plus 6. Okay, so x cubed plus 2x squared plus 6. Okay, so with this one also, we have to add the like terms together. We have the one cube term here, another cube term here. So we have s cubed plus s cubed. Don't forget that the coefficients are all 1, 1. So 1 s cubed, we have another 1 s cubed here. Then we are going to have 2 s cubed. Then we have minus 2s squared here, but we have plus 2s squared here. So minus 2s squared plus 2s squared is 0. So the square term is gone. Okay, now let's check the x term. Then we have plus 3x here. The only x term we have is this one. So it's plus 3x. It's plus 3x. Then we check the constant. There is no constant here in f of x, but there's a constant in h of x, and that is 6. And so we have plus 6. And so that is how we add two polynomial functions together. Now, let's look at how best we can. And I guess you understand that. And so with addition of polynomials, we only add the like terms together. And so take note of that. Now we are looking at f of x minus 2 times g of x. F of x minus 2 times g of x. Okay, so we have, and I advise that you take the video back if you don't understand what you are doing, so that you can listen to what I am saying, so that you can understand it very well. Okay, so now let's look at the third part. The third one, we are given f of x minus 2 times g of x. Okay, so this should be equal to f of x from the question is s cubed minus 2x squared plus 3x. Okay, so we have s cubed minus 2x squared plus 3x minus 2 times g of x, and g of x is s cubed. Okay, plus we have 4s squared, then we have minus 7. Okay, minus 7. Now because of the minus 2gx, because of the minus, if you don't put the function g of x in bracket, it will affect your answer. So take note of that. So we have minus 2 times g of x. So you put the g of x in the bracket so that you can simplify later. Now we have s cubed here minus 2s squared here plus 3x here. Minus 2 times s cubed is minus 2x cubed. Minus 2 times 4s squared is minus 8x squared. Then minus 2 times minus 7 is plus 14. Okay, so we simplify this, and we check the like terms. We have s cubed term here. Then we have another s cubed term here. But the coefficient of the s cubed term here is 1. And the coefficient of the s cubed term here is minus 2. So we have 1 s cubed minus 2 s cubed. And that will give us minus s cubed. Now we check the s squared term. We have minus 2s squared term minus 8s squared term, and we are going to have minus 10x squared. Then we check the x term. The only x term we have is 3x. Okay, so we have plus 3x, and the only constant we have is plus 14. So we have plus 14. So that is our answer for f of x minus 2 times g of x. That is what. Take note, minus 2 times g of x, so the 2 will multiply everything in g of x. Then we simplify. Then the last one, IV, we have 2f of x plus 3g of x. We have 2 times f of x plus 3 times g of x. And this will be equal to 2 times the f of x function. F of x from the question is s cubed minus 2x squared plus 3x. Okay, so s cubed minus 2x squared plus 3x. Then plus 3 times g of x, and the g of x function is s cubed plus 4s squared minus 7. Okay, so it's s cubed plus 4s squared minus 7. Okay, so now we are going to simplify. 2 times s cubed is 2x cubed. 2 times minus 2s squared is minus 4s squared. 2 times plus 3x is 6x. Then 3 times s cubed is 3s cubed. 3 times 4s squared will give us 12x squared. Then 3 times minus 7 will give us minus 21. And this will be equal. Now we look at the like terms. So we have one cube term here, another cube term here. But this one is 2s cubed. And this one is 3s cubed. So 2, because they have the same term, we add the coefficient. So 2 plus 3 will give us 5. So we are going to have 5s cubed. Then we check the square term. We have minus 4x squared. Then we have another 12x squared. So minus 4x squared plus 12x squared will give us 8x squared. So we have 8x squared. Then we check the x term. The only x term we have is 6x. So we have plus 6x. And the only constant we have in the expression is minus 21. So we have minus 21. And so that will be the answer. So in general, that is how we add and we subtract polynomials. When we are adding or subtracting, we check the like terms. Then we simplify them. If it's addition, we put them together. If it's subtraction, we subtract one from the other. So in general, that is how we add and subtract polynomials. So take note of that. In general, that is how we add and subtract polynomial functions. That is how we add and subtract polynomial functions. Okay, so now, still under algebra, we are going to look at multiplication of polynomials. We are going to look at multiplication of polynomial functions. Multiplication of polynomials, and we are going to look at how best we can multiply polynomial functions. So we are also going to take an example. Let's say f of x is equal to, we have x squared minus 5x plus 6. Then we have g of x is equal to, then we have x squared minus 5x. And we have to find, let's say I. We have f of x dot g of x. This is what we are given. So we have f of x dot g of x. Then I. Then we have 2 f of x dot 3 g of x. So let's assume that this is what we are given to simplify. And take note that with the multiplication of polynomials, we are going to apply the first law of indices, or we are going to apply a law in indices. And very soon you will understand what I am talking about with the multiplication of polynomials. Don't forget that when we were looking at the addition of polynomials, we said that if it's addition of polynomials, you add the like terms together. Subtraction, you subtract the like terms together. So now with the multiplication of polynomials, we are given f of x to be x squared minus 5x plus 6. And we have g of x to be equal to x squared minus 5x. Then we have to find f of x dot g of x. That means we are supposed to multiply f of x by g of x. Then we are also given 2 f of x dot 3 g of x. That is, we multiply 2 by the f of x function. Then we multiply it by 3 times the g of x function. So we are going to look at how best we can do that multiplication. Now the first one, we have to find f of x dot g of x. And this is equal to the f of x function is x squared minus 5x plus 6. Okay, so x squared minus 5x plus 6. We are multiplying this by g of x. G of x is x squared minus 5x. Okay, so with the multiplication of polynomial functions, what we are going to do is each term in the first bracket will multiply the second bracket. At the end of the day, we simplify. But take note that from the first law of indices, we said that if you have two numbers of the same basis, numbers of variables of the same basis multiplying, what you do is when you keep one of the basis constant, you add the exponent together. This is what you are going to use when we are dealing with multiplication of polynomials. So you have a exponent m times a exponent n. What the law of indices is saying that if you have two numbers or variables of the same basis multiply, when you keep one of the base constants, you add the exponent together. And the exponent of this expression is m. That of this is n. So because the bases are the same, in simplifying this, we keep one of the base constants, then we add the exponent together. Now, let's look at an example here before we solve the question. Now, if you have 2 exponent 3 times 2 exponent 2, according to the law of indices, when you have the same numbers of the same basis, you have the expression of the same basis multiplying. According to the law, you keep one of the base constant, then you add the exponent together. That is 3 plus 2. And this should be 2 raised to the power 5. And the answer is 32. Now, let's look at something. 2 raised to the power 3 is 8 here. 2 raised to the power 2 is 4 here. When you multiply 8 by 4, you are getting 32. And this is the same as what we had here. And that is what we are talking about. So if you have numbers or variables of the same basis multiply, according to the law of indices, when you keep one of the basis constants, then you can add the exponent together. And that's exactly what we are seeing here. Okay, so now back to our question. We are given f of x dot g of x. Okay, so now the first term, that is x squared, will multiply x squared minus 5x. Then minus 5x will also multiply x squared minus 5x. Then plus 6 will also multiply x squared minus 5x. So in simplifying, take note now you understand what we said in this. Is when you have the variables of the same base multiplying. When you keep one constant, you add the exponent together. So 2 plus 2 will give us 4. That is x squared times x squared. When you keep one of the x constant, then you add the exponent together. So 2 plus 2 is 4. Then you have minus 5, then x. Don't forget that you have x squared here, then you have another x here. And this one is x exponent 1. But x exponent 1 is the same as x. That's why the 1 cannot be seen, but there is 1 there. So if you are simplifying, don't forget that when you keep one of the base constants, you have to add the exponent here to that exponent. So 2 plus that 1 will give us 3. So we have exponent 3. Then minus 5 times minus 5x times x exponent 2. Remember that this x here has exponent 1, but x exponent 1 is the same as x. That's why the 1 cannot be seen. And so we have our minus 5 here, but we have x exponent 3. I guess you know why it's 3, because there is another x exponent here. So x exponent 1 times x exponent 2 will be x kept constant. Then we add 1 to 2, and that will give us the 3. Okay, so minus 5 times minus 5 will give us plus 25. Then x exponent 1 times x exponent 1. When we add the exponent 1 together, then we have x exponent 2. Okay, then we have plus. Now 6 times x squared will give us 6x squared. Then 6 times minus 5x give us minus 30x. Then we now simplify. In simplification, we look at the like terms. The only x4 term we have is this one. So we have x exponent 4. Okay, then we look at the cube term. We have minus 5x cubed minus 5x cubed. Minus 5 minus 5 will give us minus 10. So we have s cubed. Then we check the square term. We have 25s squared plus 6s squared. Because they have the same term, we now add the constant coefficient. So 25 plus 6 will give us 31 there. So we are going to have 31 x exponent 2. Then the only x term we have is minus 30x. So that's going to be the answer. So the answer after multiplying f of x by g of x is x exponent 4 minus 10x exponent 3 plus 31x exponent 2 minus 30x. And so this is the answer after multiplying f of x by g of x. So when we look at the second question, you multiply 2 by the f of x. When you are done, you multiply 3 by the g of x. Then you simplify. That is all. But take note, with the multiplication of polynomials, the first law of indices is very important here. When you have numbers or variables of the same basis multiplying, what we do is we keep one of the base constants, then we add the exponent together. So I guess you understand this. If you are a little bit confused, you can pause the video, you look at what is on the board. You have a book, your own pen, your calculator, then you follow what we have on the board. You can take the video back so that you can understand what I am saying. Now we look at the second question. we look at the second question. Now, with the second question, we are asked to find 2 times f of x dot 3 times g of x. Okay, so let's find 2 times f of x first, and that will be 2 times the f of x function is x squared minus 5x plus 6. Okay, so x squared minus 5x plus 6. So in simplifying this, 2 times x squared is 2x squared. 2 times minus 5x is minus 10x, and 2 times 6 will give us 12. So we are done with the 2f of x. Now let's find the 3g of x, and this should be 3 times the g of x function is x squared minus 5x, and so we have x squared minus 5x in bracket. Then we simplify. 3 times x squared is 3x squared. 3 times minus 5x is minus 15x. And now the question says 2f of x dot 3 g of x, and this is equal to, don't forget that 2 times f of x has now given us this, and so we have 2x squared minus 10x plus 12. We are multiplying this by 3g of x, and 3g of x too, we have 3x squared minus 15x. Now we are going to simplify this expression. So 2x squared will multiply everything in the second bracket. The minus 10x will multiply everything in the second bracket. Then plus 12 will also multiply everything in the second bracket. Now, I want to solve it on the left-hand side of the board so that we can understand what you are talking about. So still, we are talking about algebra in polynomials. Algebra in polynomials. And what we are talking about is multiplication of polynomials. So let's continue. Now, 2x squared. Now, we have 2x squared will multiply the second bracket. That is 3x squared minus 15x. Then the next term is minus 10x. So minus 10x will also multiply the second bracket. That is 3x squared minus 15x. Then plus 12. Plus 12. Okay, so let me continue it here. Plus 12 will also multiply the second bracket. That is 3x squared minus 15x. Okay, so we simplify now. Now, 2 times 3 will give us 6. But we have x squared times x squared, and that will be x exponent 4. I guess by now you know why it's x exponent 4, because we keep one of the x constant and we add the exponent together according to the first law of indices. Okay, so then 2 times minus 15 will give us minus 30. But we have x squared here and we have x here. Don't forget that this x, the exponent is 1. So 1 plus the 2 will give us 3. So x exponent 3. And minus, we have 10 times 3 will give us 30. Then we have x. This is x exponent 1, then this is x exponent 2. So we add the exponent together when one of the x is kept constant. So 1 plus the 2 will give us 3. Then minus 10 times minus 15 will give us plus 150. Okay, so 150x, this will be exponent 2. Why is it exponent 2? The x here has exponent 1, the x here has exponent 1. So when we are keeping one of the x constant, then we add 1 to 1, and that will give us 2. Okay, then plus, we have 12 times 3, and that will give us 36x exponent 2. Then we have minus, that is 12 times 15. So we can simplify that. 12 times 15, you have 5 times 2, 10, 0. Remember 1, 5 times 1, you have 5 plus 1, you have 6. 1 times 2, you have 2. 1 times 1, you have 1. So you have 180. That is 180. Okay, so 12 times minus 15 is 180 here. Then we have x, because there is no x term here. Okay, so take note of that. I guess you understand this symbol calculation. Okay, if you have calculator, you can also use the test. 12 times minus 15, realize that it is minus 180. So we now simplify. Now we check the like terms. The only x exponent 4 term is 6x exponent 4. Then let's check the cube terms. We have minus 30x cubed minus 30x cubed. So minus 30 minus 30 will give us minus 60x cubed. Then let's check the x squared term. We have 50 here. We have 150x squared. Then we have another 36x squared. When we add 150x squared to 36x squared, we are going to have 186. That is 186x squared. And the only x term we have is minus 180x. So this will be the solution to the second part of the question. You can take the video back, look at the question, and see the solution we have. So in general, that is how we multiply polynomials together. That is how we multiply polynomials together. And that will be all for now on this episode. Thank you.